Good morning, and welcome to this Conservation Applied Research and Development, or CARD webinar, which is going to report on their findings from a 3-year-old DOE and CARD-funded project that assessed the energy and non-energy benefits of power over Ethernet technologies. Thanks so much for joining us. I'm Mary Sue Lobenstein, and I'm the Research Planning Director at the Minnesota Department of Commerce, Division of Energy Resources. In that role, I identify and analyze gaps within utility conservation improvement programs and coordinate and plan research to fill those gaps. The CARD program is a major tool of that work. With me today is Adam Zoet, an Energy Planning Director at the Department of Commerce, where he specializes in the regulation of electric and gas utility energy efficiency programs. Adam's work includes leading the evaluation of energy efficiency program cost-effectiveness methodologies, overseeing the development of an online platform that captures energy efficiency program data that reports on over 100 utilities and 100 electric and gas utilities, formulating regulatory policy guidance, managing research grants, and assessing Minnesota's utility energy efficiency programs. He is the project manager on the research that is the subject of today's webinar and will moderate the Q&A portion of today's program. Our presenters today are Dee Sway and Lester Shen from the Center for Energy and Environment. Dee is a building energy analysis engineer at CEE, where she works mainly on building energy efficiency projects, including dynamic building simulations, energy analysis, troubleshooting for energy models, and energy code program review and design and simulations. She has a master's degree from Georgia Institute of Technology in high performance building, with an emphasis on building performance simulation and analysis. As a senior research engineer at CEE, Lester is Director of Innovative Technologies, where he keeps abreast of the latest technology and energy efficiency trends that help inform and enhance the development and delivery of current and future CEE projects. He also serves as a technical and program advisor to CEE projects and services and has been working on projects dealing with both residential and industrial energy efficiency. Welcome, Dee and Lester. We look forward to the presentation. Before we start, I'd like to go over just a few webinar basics, which are probably familiar to most of you. All attendees will be in listen-only mode, and we'll try and answer all questions at the end of the presentation. But as questions occur to you, please type them into the Q&A box and send them to all panelists so we can organize the questions. We'll do our best to answer all questions within the time allocated, but if for some reason we don't get to some, we will answer them after the webinar. This webinar is being recorded and will be available on the department's website. The slide set from the webinar will also be available. This webinar is one in an ongoing series designed to summarize the results from research projects that are funded by Minnesota's Applied Research and Development Fund, which was established in the Next Generation Energy Act of 2007. The purpose of the fund is to help Minnesota utilities achieve their energy savings goal. About $2.6 million is set aside annually for the CARD program, which awards research grants in a competitive request for proposal process. Results from CARD projects provide utilities with data to enhance energy efficiency program designs within their conservation improvement program portfolios. As this pie chart shows, CARD projects funded to date have been in all building sectors, as well as some that cross multiple sectors. Today's webinar is in the commercial sector, and we'll discuss results from the recent CARD project that demonstrated the use of IT network switches to power and control lighting, plug loads, and HVAC equipment in a variety of buildings. Now I'll turn it over to Dee for today's presentation.
Thank you, Mary Sue. Thanks everyone for joining the webinar with us today. And during the presentation, I'm going to go through the research objectives first, and then give an introduction of the PoE technologies, and then present the results we got from the site demonstrations, and at the very end, the concluding remarks. This project was funded in part from grants for the U.S. Department of Energy, Office of Energy Efficiency and Renewable Energy, and the Minnesota CARD program. The purpose of the study is to assess how Power over Ethernet or PoE technologies can be used to substantially reduce commercial building energy use by increasing the proportion of equipment under automated control. The goals of the demonstrations are listed on the slide. We started with what research would always do as the first step, which was to assess the market receptiveness. We were targeting on commercial and institutional markets, and then we analyzed the applicability and energy saving potential of the technology by testing it on 5 sites. This includes to demonstrate the feasibility of applying PoE technologies under standard design and construction practices, and to assess the energy and cost savings. We were also looking at the potential of providing energy management opportunities where they typically are not available. And finally, with all the work done in the project, we want to formulate approaches to spur adoption of the PoE technologies. Some of the research at these demonstration sites are still ongoing, and there will be a final report available this summer. So Power over Ethernet, or PoE, currently distributes low voltage DC electricity throughout commercial buildings, and that is via the building's local area network. You might already be familiar with those PoE devices used in the office, such as digital VoIP phones, Wi-Fi access points, and security cameras. Data and power are distributed from the data centers and the server closets embedded in the building to the various connected devices. As evolving PoE standards allow higher power loads, more and more building end users are networked via PoE using the Ethernet cabling infrastructure. This includes lighting, computer workstations, and motorized shades, and overhead fans. So this is a picture of what a general server room looks like. The network switches are normally located in those data center or data closet. And here's how the network switches look like. The switches provide low voltage DC power and also data through the Ethernet cables. The cabling can be done by low voltage electrician, so you don't need a licensed high voltage electrician, which is normally more expensive. Cable doesn't have to be in conduit, so IT staff can also pull the cables. And the cables go directly into end-use system. Those are the same cabling infrastructure for office computers and phones. So the system is not something that you can only find in the large buildings. Small buildings are likely to already use PoE switches for powering some of the devices. This is a picture of the type of cable used in the system. And they are 8 wires, 4 twisted pairs, transfer both data and power. So the first PoE standard was ratified in 2003 with 15.4 watt of power allowed from each port of the network switch. Since then, updated standards have resulted in higher powered PoE network switches to be available. And over the last 3 to 4 years, as power levels exceed 60 watts, the variety of end usage that could be powered by PoE increase the potential of PoE to be a backbone for connected devices and DC distribution. 100-watt PoE switches are now coming onto the market. The network switch is the power sourcing equipment, or PSE, with each PoE power devices connected to a port of the network switch. All of these connected devices will be IP addressable and can be monitored and controlled over the network or from the cloud. Network management software can be used to monitor the power loads at each port, providing submetering capabilities. The network connection of the PoE devices also allow integration of these devices and their sensors with other networked building systems, such as building automation system, BAS, or building security systems. Above are a quick introduction of the PoE technologies and devices. And now we're going to talk about the site demonstrations. So the goal of this project, again, is to demonstrate the energy opportunities of PoE technologies and systems. And over the 3-year project, PoE systems are studied at 5 demonstration sites. At least 2 PoE systems were studied at each site. The project began in October 2017, and during the budget period 1, 2 sites were recruited, built out, and monitored. They were an office remodel and a middle school renovation. We are currently in budget period 2, and we're working on 3 sites. They are a DC-powered hotel that has been running for 2 years, a high school renovation, and another office remodel. So the CEE office is the very first site we remodeled and monitored. The admin office area was remodeled with 17 office cubicles installed into the site, with 1 row of 8 cubicles lit by the legacy line voltage overhead lighting, and the adjacent row of 9 cubicles lit by new Philips PoE luminaires. The fluorescent lights were used for the 8 cubicles at first, and then they were replaced by LED lamps, so we get to compare LED versus PoE as well. The PoE luminaires were dimmable, and each fixture had an occupancy sensor and a photocell. The AC lights were not dimmable, and the bank of lights were controlled by a wall switch. For the PoE lights, data was collected by the network switch management system, and for the AC fixtures, the usage were measured from a dedicated circuit in the electric panel. The table here shows the loads per fixture for the AC luminaires compared to the PoE luminaires. The savings from replacing the T8 fluorescent lamps to LED replacement lamps saving was over 50%. And the PoE luminaires use the same LED lamps as the replacement LEDs, with the exception that the ballast and driver was replaced by a PoE LED driver. Each PoE luminaire was dimmable with an occupancy sensor and a photocell sensor. So with the PoE lights, we were able to customize the light level for each cubicle, and that results in about 40% savings. We also test a PoE All-in-One Workstation in the office against a PC workstation. The PoE workstation, which is called Thin Labs, it has 2 external monitors, and it was used for spreadsheets, word processing, online training, and webinars. The user reports no difference in performance between the 2 machines. The PC workstation drew about twice the power loads of the Thin Labs workstation. And the Thin Labs can also be AC powered, so we tested the energy use of that as well. There was little difference in power draw whether the Thin Labs was powered by line voltage or by PoE. The AC power data was collected using hobo loggers, and the PoE power data was collected from the network switch management system. One last comparison we did on this site was with the Thin Client workstation. In the CEE Landing Center, each loan staff used a Thin Client workstation. So similar to the Thin Labs, those 10-zig Thin Client could be powered by either line voltage or by PoE. Once again, the AC power data was collected using hobo loggers, and the PoE power loads was collected from the network switch management system. The results also show about 45% saving switching from AC Thin Client to the PoE ones. And the performance of the AC versus PoE mode of the 10-zig Thin Clients are very similar. An advantage of the PoE mode is that the network switch can be scheduled to turn off the power to the Thin Client during off hours, and that eliminates the standby power. Our second site is a remodeled public middle school. The renovation includes multiple classrooms, and we picked 2 adjacent classrooms for the test. One installed with Igor PoE luminaires, and the other one with just normal line voltage LED lights. So those 2 classrooms are side by side. Both have daylight coming through the existing south-facing window. The PoE classroom has 16 PoE 2x2 troughers, and the control room accommodated 12 AC-powered 2x4 troughers. Both systems have daylight control, occupancy sensor control, and both have wall switch that can dim the lights. The two systems provide equivalent light output to the two classrooms. The AC-powered lights energy use was monitored at the panel with CT and E-gauge, and the PoE lighting fixture energy use was pulled from the network switch with SNMP script. The lighting performance of the two systems are comparable. From the result chart, we can see that the two lines have pretty similar slopes, but the PoE system has a non-zero standby usage. This is associated with the use of the network switch. So comparing the PoE system to an AC-powered digital addressable lighting interface lighting system, which is also called the DALI lighting system, or a digital multiplex, a DMX lighting system, that might be a more apples-to-apple comparison in both functionality and the standby needs. Upon examination of power use profiles at different points in the year for each classroom's lighting system, PoE power consumption is consistently higher than the traditional AC lighting system. At an average lighting level of 470 lux for each of the classroom, the power for the line voltage fixture was about 360 watts, while the PoE lighting system was about 460 watts. The power to the original lighting system of the 2x4 troughers with T8 lamps was about 1200 watts. So both LED systems provides a significant power reduction over the original T8 lamps. To further investigate the component level power used of the PoE system, we broke down the power draw by non-effective and effective sources of the PoE system. So the chart here shows more straightforward that the non-effective power, which is the standby load plus other losses, can be a sizable portion of the total usage. This raised the question of if it is worth to spend the extra wattage for the switch to have a more detailed fixture level control. The lighting remodel also includes a public school district media and technology service, which is called DTMS. This is an office area. Before, they were using the 2x4 T8 troughers. And they renovated the space with dimmable ubiquity 2x2 light panels. The IT staff installed the lighting system and a PoE Plus network switch, providing 25 watts to each luminaire. Because the light panels were placed in a suspended ceiling and attached by a cable, the IT staff could easily move the panels over each staff's workspace and customize the light level delivered to each work area. The calculated power load of the original fixture was about 1850 watts at uniform brightness of 75%, and the total load of the ubiquity light panels in the office area was measured at about 300 watts. Since the light panel are dimmable, the IT staff, they were able to vary the brightness from 5% to 75% based on each staff person's preference. The total load of this configuration was just 167 watts. Based on the energy use we see at the classroom and at this office, it is pretty clear that the use of PoE lights can bring significant savings compared to fluorescent lights, even with the standby load. And when the light level can be customized at the fixture level to accommodate user preference, PoE system can bring even more savings than the LED lighting system which has no standby load. Above are the two sites we had finished testing. We have 3 more sites that are currently under demonstration. The first one is ACGC, which is a junior senior high school in Grove City. The remodeled building has PoE powered lighting, VAV controller, and controller for an AV system. All PoE usage are read from the switch. For comparison, we are also monitoring AC-powered lighting system, VAV controllers, and AV controllers as baselines. The AC lighting we're monitoring is a DALI network lighting system in the elementary school building. This one, as we mentioned before, will be an apples-to-apple comparison to the PoE system. The slide here shows the power draw by the PoE lighting system in the offices of ACGC Junior Senior High School over November and December 2021. The maximum draw is about 350 watts with a minimum draw of 80 watts. Notice that there appears to have two baseline draws. One during the week at one is during the weekdays at 150 watts, and the other one during the nights or weekends at about 80 watts. The school keeps some lights on for 24 hours during the weekdays and then are shut off at night and also during the weekends. The higher base load compared to the AC power lighting system are used to power the PoE system devices that enable more detailed controls and data submetering. The system devices include a network switch that connect the PoE devices to the local area network, as well as being the power source equipment to those devices. A network server that control the switches and communicate with the power devices. And the sensors, such as occupancy sensors and photo cells, and controls like wall switches that are used to operate the power devices. This slide here shows the power draw by the AC-powered DALI lighting system of the ACGC Elementary School admin office. The maximum power draw for the lighting system is about 1,000 watts, and the base load power of the DALI system is about 100 watts. The slide here shows schematic of a typical DALI system. To provide the same functionality as the PoE lighting system, the DALI system requires a DALI controller, which function as a PoE switch, and an additional DALI power supply. A network gateway that connected the controller with the management system for network control, and also the sensors, the wall switches, ballast drivers that are used to operate the power devices. This system will consume baseload power in the same way as the PoE system as part of its normal operation. The table here shows a comparison of the power draw for the 4 lighting systems monitored in the Edina and ACGC schools. Notice that the power per LED fixture is of the same magnitude for all the systems, ranging from 21 watts to 48 watts. And similarly, the networked lighting system have similar base load per fixture value of about 3 watts to 5 watts. For measuring the PoE energy use on this site, we have developed a method to collect data without having to actually go on site. This includes the main use of a cloud-based management tool, which we had a shared account with the project team, so that they can upload the data to the account and we can download them from our end. It also includes generating SNMP script to automatically downloading selected data from their server to their database and replicate the data to the management account. We're not going to go into this rabbit hole here, but the detailed information will be included in the final paper. The second site we're working on right now is an office building, and we call it the SPPA office. They are remodeled to use a PoE network lighting system, PoE controlled outlets, and AV system controls, and also VAV controllers. We are pretty excited to see how much saving the controlled plug load would bring. This slide shows the wide range of PoE lights that are now available. The photo on the right shows an AC outlet controlled by the PoE relay, providing plug load scheduled shut-off control. The Minnesota Energy Code requires that 50% of outlets in the offices should be with controlled circuits. The last site is the Sinclair, a Marriott Autograph Hotel in Fort Worth, Texas. The building originally constructed in 1929, and it has been converted into a DC-powered luxury hotel. The hotel is equipped with PoE devices in all of the guest rooms, including lights, monitored shades, TV, minibar, and bathroom mirrors. The high voltage DC electricity is transmitted through the building using the volt-server digital electricity system, which powers the network switches distributed throughout the hotel and in all the guest rooms to power the devices with low voltage DC electricity through PoE. This slide here shows how AC power from the utility is converted to the DC power, which is then distributed throughout the building. We are collecting the power data from both the volt server transmitter and the Cisco switches. So above are all the results we got from the site demonstrations. We learned so far from the demonstration that the primary savings still comes from the technology of the end use. We see this from lighting system retrofits and also the comparison of the workstation energy use. The savings from eliminating the AC to DC conversion at the power devices is pretty nominal, but can add up with scale. And the standby loads of the PoE systems, which includes the switches, the gateway, and the servers, can be a pretty sizable portion of the energy use and cost. The IP addressable power devices allows individual device control, but whether that can bring energy and cost savings or not actually depends on if you can use that detailed level of control on site. Another efficiency gain and management opportunity that the PoE system can provide is the integration with other systems, such as with HVAC system and security systems. This can be done through the use of APIs, BACnet, and SNMP. We use a lot of SNMP scripts during our site demonstrations. A non-energy benefit is that the installation costs may be lower since the cost of low voltage wiring is typically less expensive than AC electrical wiring. The PoE network devices will not require the additional electrical service. Another non-energy benefit is that the PoE system enhances the flexibility of a space in terms of being able to better accommodate different space use requirements and different tenants' preference. This is especially useful as after COVID, a lot of office area are renovated into open office spaces, and the PoE lighting fixture can be moved around easily to new locations without a need for high voltage electricians. And the light level of each fixture can be also customized for different users. We also see the issue that the responsibility of facilities, IT, and control contractors needs to be addressed. During our site demonstrations, we see electrical system designers, control contractors, and ITs work together on the installation of PoE systems. But we also see on-site IT staff takes more responsibility in managing the systems, but there are also sites that we're having a hard time identifying who is actually in charge of those systems. And finally, we believe that the PoE offerings and capabilities will continue to develop as PoE standards evolve. And that concludes the presentation today. The final card report will be available this summer. Thank you.
Thank you, Dee. That was a great presentation. If you have not already done so, please type any additional questions into the Q&A panel and send them to all panelists. Adam, do you have questions for Dee or Lester?
Thanks, Mary Sue. Yeah, it looks like one of the questions is, what would you say is the most significant barrier to broader market adoption of PoE technologies?
Yeah, I can answer that. So the PoE lighting systems are still a fairly new technology on the market. So during the beginning of this project, which is around 2016 and 2018, we saw the electrical contractors they presented bids for the PoE system with a much higher price than equivalent AC lighting systems. And this likely was because they had not installed those systems before, and so they want to cover their risks. And they also charge the high voltage electrician rates when a low voltage electrician could be doing the work. But recently, we have had positive feedback from the electrical engineer we work with in this project, and he has been seeing more reasonable cost numbers in the bids, and it appears that the market is moving in the right direction. And we had expected to see PoE cost about 15% lower than normal AC costs, but typically bids seems to be coming in the same amount. Yeah, I hope that answered the question.
Yep. Is there any way to get around the standby usage energy penalty for some PoE technologies?
Well, the standby loads are they are essential to run the control system and to also keep them communicating with the devices. So in other words, so the standby usage is the cost that is paid for the control and management that the network system provides. If the energy and non-energy benefits of the network system outweighs the cost of the standby use, then you can make the case for employing this system. But there can be ways to reduce the standby use penalty by optimizing the network system to the level of control truly needed for the space use. So as we see from the results from those demonstration sites, determine how smart the space really needs to be, and grouping devices with different level of controls that are pretty important to help reduce the standby use.
Thanks, Dee. Let's see. How do you see this technology being incorporated into utility SIP programs, either now or in the future?
Lester, do you want to talk about that?
Sure. I think if you look at what Dee earlier said, that a lot of the energy savings basically comes from the end user, the power devices themselves. So obviously, with PoE lighting systems, we're already talking about LED lighting. So those would fit under the typical LED lighting rebates. If you look at the PoE lighting systems themselves, they are network lighting systems. So there are already existing rebates for network lighting controls. And if you also consider with PoE systems that since the lights are all connected to individual network ports, which can be controlled through the network management system, we are not only talking about network lighting systems, but we're also talking about luminaire level lighting controls. And so in the future, as rebates or utility programs have incentives for luminaire level lighting controls, I think PoE systems can qualify for those, since each lamp or each light will be IP adjustable. With regard to the other PoE technologies, again, I think it depends on what might be qualify for savings. We have motorized lights, so that might fall under or motorized shades, so that might fall under daylighting. There are computer workstations, plug loads. I think the other piece is that the PoE systems allow us to do device level monitoring, which doesn't require additional expense for monitoring equipment and can easily be monitored via the existing network management systems. So we can read what the power draw is across each of the ports. This level of monitoring is a benefit that can be used with future possibilities in terms of monitoring performance and allowing maybe performance-based incentives or I guess utility programs so that we can easily do that with PoE. And then also in the future, we have the ability to look at how these devices can be used in integrated systems. And so I know that there's been some work looking at how we can create utility programs that are beyond widgets or not just the devices, but how the systems work and how they're integrated, and what the benefits to energy performance can be brought about. And the fact that you can create these synergies using on the systems level, we being a already IT network system could fit under that. So that would be a possibility for a future utility program. And then finally, as we start looking at how the grid can also be, I guess, the movement towards grid interactive efficient buildings and looking at demand response and some of the ability to influence the power demands of a building, the management and control that PoE provides can also be incorporated into a future utility program. Does that make sense?
Makes sense. Yes, thank you. Let's see. What areas for further research do you think are needed related to PoE technologies?
I think when you look at the delivery of low voltage DC via PoE, that you can look at additional devices that might be that might fit within the system. Obviously, lights or something that is clearly being marketed and implemented in buildings now. You look at the Sinclair Hotel and you're seeing the ability to use motorized shades, even a mini bar. The fact that many that power supplies are already, typically DC, which means that a lot of the devices like workstations where you have you have to go from AC to DC using wall warts and these sorts of things, they are basically DC devices. So they could be powered by PoE, either through a PoE cable or even USB. You have DC motors. So I think that is a possibility to look at how we can expand the breadth of applications of PoE. I think that's something that's worth looking at. The other possibility is, as I said previously, the fact that we have a network management system that allows us to monitor devices. So how monitor and control. So the fact that that PoE could fit quite easily with the development of grid interactive efficient buildings, I think is also attractive and something that I think is an area for future research. Again, the fact that PoE is powered, is basically a distribution, a transmission and distribution system of DC electricity through a building. I think looking at the possibility, in fact, of DC buildings is another thing to look at, where you can either look at buildings or say a community of buildings that perhaps is generating DC power through distributed energy sources such as local PV, solar panels, fuel cells, battery storage, which basically then means that you generate DC power through those sources, and you won't need an AC inverter, which has built-in inefficiencies. Even though it may be a couple of percent, it's still an inefficiency, whereas you can go directly from DC to DC. I think that's a benefit, and so the development of DC powered, or I guess the implementation of more DC powered buildings would be another area for further research and demonstration.
Excellent. Thanks, Lester. Let's see. I'm not seeing any other questions that have been submitted at this point in the Q&A panel. So I'll kick it back to you, Mary Sue.
Sure, thanks. Thanks again for the presentation and the answering of the questions so thoroughly, Dee and Lester. And thank you, Adam, for facilitating the Q&A. If you do have follow-up questions about the CARD project, feel free to contact one of us. And a recording of the webinar and the slide set will be available on the department's website in a few weeks, and the final report in a couple of months. When available, you can link to either of these from our quick links on our Applied Research and Development webpage, which is on this slide. The R&D webpage has a lot of additional resources and information related to CARD and the CARD program and research projects, which you can check out by going to the address at the bottom of this slide. Thanks for participating in today's webinar. We really appreciate your interest in CARD projects, and I want to take a minute to mention 2 upcoming CARD webinars. In April, on the 28th of April, Franklin Energy will be join us to discuss the energy savings potential of network lighting controls and the challenges of deploying them in small businesses through some real-world projects that they installed them in. Then on July 13th, this one just hot off the presses, the Citizens Utility Board of Minnesota will present the results of their study, which investigated ways to increase the access to utility energy efficiency programming for underserved populations. You can keep abreast of upcoming webinars and other news related to the Minnesota Conservation Improvement Program by signing up for SIP updates on our email list. You can use the link on this slide to do that. In the meantime, feel free to contact me directly if you have suggestions or questions about the CARD program or CARD webinars. And as a final note, there'll be a short evaluation that launches after the webinar. Please take a few minutes to fill it in and let us know how we did. Thanks again for attending and have a great rest of your day.